Hi, my name is Susan John. I'm a math teacher at Ocean Lakes High School in Virginia Beach, Virginia, where we have the Math and Science Academy. This video is supported by the Secondary Mathematics Professional Development Center at Radford University with funding from the Virginia Department of Education through the Mathematics and Science Partnership Grant Program. This is the fourth video in a series. The purpose of this video is to help teachers in Virginia help their students become adept at using Desmos, especially the classes where they will be taking the Algebra 2 SOL. So it's specifically geared towards helping your students learn how to use Desmos with the Algebra 2 SOL topics. This video was specifically about using data to find regressions and predictions on Desmos. So let's get started. Okay, so these are some sample problems. I'm not sure how it's going to work for the actual SOL because there is a way to import data that you have in a Excel file or a Google spreadsheet into Desmos. So I'm not sure how that will work, if they will have that on the SOL, a way to import your data into Desmos. So I'm going to proceed as if you will be required to type in the data. So the first thing that we're going to need to do is go to Desmos. So the website is www.desmos.com, and you want to use the graphing feature. So you want to choose Start Graphing. Okay, so if you want to enter data, you go over to this plus sign in the upper left, and you want to add a table. And it will open a table, and then you can just enter the data. I find it easier to use my keyboard, but you have a keypad over here that you can use. So the data for our first problem, we're going to have our X1 column be time in seconds, and we're going to enter 1, 2, 3, 4, and 5. So if you want to hit 1, and then you can, this is enter. I find it easier to just use the keyboard. And you can see I actually was just hitting enter from a certain point because it started sort of like a Word program will do. It'll just automatically give you the next integer if it detects the pattern. So then we were comparing this time in seconds to the Y1 column is height in feet. This problem is about the height of a baseball. So 93, 149, 174, 168, and 127. Okay, so you probably are going to have to set your own window. The way that you set the window is you go over here to this wrench tool, and that's your graph settings. So we can see that our x's go from 1 to 5 and our y's go from 93 to 127. So I want to have an x max probably a little bit beyond 5. So I would probably do the x window to 6, and the y window I probably would do to like 130. So I'm going to click the wrench, and the x-axis I'm going to just change to 0. I'm going to have that go up to 6, have the step just be 1, which would be default anyway. And then the y-axis, I'm going to go from 0. And again, the biggest y value in my data set was 174. I think I said 127 before. It's 174. So I'm going to go to maybe 180. And then if you want to change the step maybe by 5, that's sort of up to you. Okay, so then remember you can hold down the left button on your mouse or keypad and kind of move this around to see all your data points. But you can see this nice quadratic pattern. Okay, so on your SOL question, this particular question gives you some choices about which equation best models the data. So I'm going to go over 2 different ways to find that equation. You can just do enter your equation choice in for Y2 and then, or for the next line, and then see how it compares to your data. So we would go over here to add, and we want to put in an expression, which is really just an equation. So one thing to keep in mind is important that your variables are x1, y1, and since we're trying to get an equation to go with this data, we want to make sure we stay with those variables. So let's put in our first answer choice, and so you want to do y, and then if you hit 1, it automatically reads that as a subscript because it's assuming that it's going to go with the data. Here's something else that is very, very important. When I was practicing for this, I was getting very frustrated because I kept putting in an equal sign and it wasn't working. And I finally realized that it was super important that you use the equivalent symbol instead of the equal sign here. So to get that, you go over to functions and to miscellaneous. No, oh, you go to ABC. Okay, I knew it was something. Go to ABC and that opens up more of a QWERTY keyboard, and then there is the symbol that you need. So that's really, really important. That symbol right there, if you don't use that, if you try and use an equal sign, then you're going to get frustrated because it's not going to correspond to the data. It's not going to work in Desmos. All right, so my first answer choice was, I'm going to go back to the numeric keyboard. So I'm going to do negative 16.07 times the quantity x minus 3 and then squared, so that goes right there, and then plus 174 and hit enter. Oh, see what I did? I didn't put the x1. You just hit 1 and it works perfectly. So you can see that when you do that, it gives you the r squared value. So the closer to 1, the better. So this isn't terrible, but we have some other choices. Now we can see the shape of the data points, so we should be able to eliminate choices B and D and just try choice C as a comparison to see if A or C is the better fit. So that one was negative, I'm just going to backtrack here. Negative 16.07. Again, make sure you don't do what I just did. Make sure you hit x sub 1 squared plus 105.13x 1 plus 3.6. So and don't forget about the subscripts and this equivalency as opposed to the equal sign. All right, so you can see the r squared value is closer to 1 than our first attempt, and it looks like it fits the data points really nicely. So you would choose that answer C as the answer to this SOL question. All right, let's look at a different way to do that instead of just typing in the answer choices. So I'm going to X that out, and I'm going to, I've already got the row open to add an expression. So another way that you can do this is if you have a suspicion that this is quadratic, and according to the new SOL standards, the regression problems should be either quadratic or exponential. So you can kind of narrow down your advice to students, but you would put in some graphing form that goes with a quadratic regression. So I'm going to hit Y1, hit the ABC to open up the option for the symbol you need. And then I'm going to do the standard form of a quadratic. So that's ax sub 1. Go back, go back to the numeric keyboard, squared plus bx sub 1 plus c. And that way it tells me what my regression equation is. It gives me the same r squared value as when I entered in the equation, and it tells me what my coefficients are for x squared x and what the constant is. So this way I don't have to do trial and error, but I can generate the best regression equation with the correct coefficients and find the correct answer that way. And so either way, you would choose answer C. Let's try another problem. Okay, for this problem, we are comparing time in minutes to mass of remaining barium 122 in grams, and it says that it decays exponentially over time. So right there we are getting a head start on what type of regression we should be focusing on, and this time we're not given choices, so we'll need to use that second strategy where we actually have Desmos calculate our regression for us and then use that to make a prediction. So let's go back to Desmos. I am going to just clear out both of those things and start over. Okay, so first thing I want to do is add a table. So plus sign, add a table, set it up for me. So our time in minutes go from 0 to 4. And see, it's detected a pattern. So if I'm okay with that, I can just keep hitting enter. And the mass is 80, 56.6, 40, 28.3, and 20. I always tell my students with the graphing calculator, take a second to double check the accuracy, because you can misenter one decimal or miss a digit, and then it throws everything off, but you aren't assuming that you did anything wrong, so you waste precious time. All right, so remember, you're probably going to need to set your window. If I slide this up, I actually could just use the window that I already set, but if you do need to set the window, remember that is the wrench over here, and then you just adjust the x-axis and y-axis however you want to. All right, so it did tell me that it was exponential, so that gives me a good place to go from here. So I've already got the second row open, but you can add an expression and it'll open up another row as well. Okay, so again, let me remind you, super important to use the x and y with the subscript of 1, and to also use, instead of the equal sign, the equivalency sign. So we want to use the general basic parent function form of an exponential function. So I'm going to do y1, hit the ABC to get the QWERTY keyboard so you can get the symbol, go back to the numeric keyboard, and then I'm going to do A. I'm going to use my keyboard, but you can go back to ABC if you want. A, and then parentheses, B, back to the parentheses, and then I want to raise that to the x sub 1 power. All right, so that would be the form that you would want to enter to get a exponential regression. It's a perfect fit. I have an r-squared correlation coefficient of 1, perfect, and I can see my equation has an a value of about 80 and a b value of 0.707 approximately. All right, so I need to figure out, to answer the question, I need to know what is closest to the amount of the sample at 5 minutes. So if I slide this up, I can read my graph now that I have the exponential function graphed with my data, and I can see that 5 is right here, and it gives me a value of 14.219. So if I go back over here to my answer choices, just based on that, I would say D, 14.1 grams. But I can click on that and get that point. It's not giving me, got to play around to get, I guess, exactly 5, but you would be able to choose the correct value from there. Something else that you could do, trying to move this down. Oh. Hold on one second. Let me get this moved down a little bit if I can. I don't know why it won't move. There we go. Okay. So you can just type in the equation of the horizontal line. So if you're looking for where, or for the vertical line, you could type in the different answer choices as a y. So what if I typed in x equals 5. So then I get a clean x intersection point, because I wanted to know about what was the prediction at 5 minutes. And I have a nice perfect intersection point that would tell me at 5 minutes, then the mass of the remaining barium 122 would be 14.15 grams. So then I would be able to choose answer D. At this point, pause the video and take about 15 minutes to work through the two problems. I will give you some time, and then I will move this up so you can see the rest of it. I really tried to get that all on one screen and I was not successful. So take some time, pause the video, and work on the first problem, and then I will come back and slide it up so you can see the second problem to work on as well. Right, hopefully you didn't have any trouble. Again, I can't say it enough. Remember to continue to use those subscripts that you see in the table when you add the data of x sub 1 and y sub 1, and avoid the equal sign. Use the approximation symbol instead. So hopefully you were able to come up with C as your answer. So in the second problem, now, this was sort of gave us some extraneous information from this problem. Notice they were kind enough to label the price per ticket as X and the amount of lost revenue as Y. So that sort of gives us a big clue that we're going to ignore that middle column. And so try and enter the data, come up with the correct regression, and after that, try predict the amount of lost revenue for when the tickets the lost revenue the tickets are $100 in cost. Okay, welcome back. Hopefully you had success working with both of those problems. Just to summarize, because I feel like as far as using Desmos, entering data and finding the regressions probably requires the most Desmos knowledge of all the SOL skills for the Algebra 2 SOL. So you want to add a table, and then when you go to work with the regression equation, just go down to another row, make sure you're continuing with the same subscripts of x sub 1, y sub 1, and that you avoid the equal sign. Use that approximation symbol. And if you have equations as answer choices, then you can certainly enter those in one by one and compare to your scatter plot. Or if you are just wanting the Desmos to calculate your regression equation for you, then you just type in the parent function form, again using your subscripts of x sub 1 and y sub 1. For this particular problem that is still on the screen, your choices were linear and exponential, so you would either do the y sub 1 equals a times b raised to the x sub 1 power as your form, or y sub 1 equals m x sub 1 plus b as your linear form. And then after that, you should be able to read your graph to see when X is $100, what the corresponding Y value is. There would be a lot of window setting that would be necessary here because these numbers get very big. And you can also type in X equals 100 and see a vertical line so that you can get a nice clear intersection point that Desmos will give you to get your answer for that as well. I hope this video has been helpful. If you have any questions or comments or suggestions, you can email me at susan.john@vbschools.com. Thank you.